This is the extra practice Desmos that will be like the review for the Unit 1 Topic 3 formative assessment. So the warm-up is to match the transformation phrases that have the same meaning. So let me get the slate here. Whoops. I just minimized everything. All right. So a reflection over the y-axis is going to be a horizontal reflection. So that goes at that one. And then vertical reflection is reflection over the x-axis. Those two together. Dilation with respect to the x-axis. Dilation with respect to the x-axis is a vertical dilation. A dilation with respect to the y-axis is a horizontal dilation. And then translate up or down is a vertical shift. And then translates left to right is a horizontal shift. Slide 2, match the equation to its transformation. So when you have this in parentheses here with the x, it's the reciprocal. So on the other slides, the previous slides, there were some mistakes there with there wasn't a reciprocal dilation. So here you're going to look for, when it's a number with the x inside the parentheses, you're going to look for the reciprocal dilation. So let's move all the equations to one side and the sayings in the middle, sort of. All right, so now we got these all moved around here. So vertical dilation of 1/5. You want to look for a 1/5 in front. Okay, here's one. And a horizontal dilation of 1/2. So that's the reciprocal that goes with this one. All right, and then you want to do this one's vertical reflection. So vertical reflection would be a negative in front of the log. There's a few of those. Horizontal dilation of 1/2. That's with 2, and then right 4 is this one here. So the next one, vertical dilation of 1/5. You have a 1/5 in front, and horizontal dilation of 1/5. Those go together here. And then vertical dilation of 3. That'd be 3 in front of the log. That's this one. Horizontal reflection is the negative in front of there, and then left 2 would be here. And then vertical reflection would be a negative, and then horizontal dilation of 1/3. That's the 3 there, and then up 2. Those go together. And then vertical reflection would be a negative in front of the log, and then right 2. Oops. I'm going to grab this. It goes here. And then vertical dilation of 2. So I go, one goes at that one, and then the last one, horizontal. So let's read the rest of this. Vertical dilation 2, horizontal reflection is this negative, so reflected over the y-axis and down 4. And then the last one, horizontal dilation of 5, that should be a 1/5. I'll change that. And left 1, so this should be a 1/5 instead of a 5 there. So I'll fix that mistake after I do the video here. All right, on 3 here, the key features of a log graph. So you want to look for the vertical asymptote when you're talking about the domain. So the vertical asymptote here is 2. So this goes from 2 to infinity. So the domain on every log function is going to be affected by the vertical asymptote. The range for every log function is negative infinity to positive infinity. And then what is the asymptote? It's right here, x equal 2. Decreasing, that's NA. Then increasing, this same as the domain. All right. And then what's the domain of this graph? So once again, you'll look for the asymptote here. It's at negative 2. So negative 2 to infinity. The range, like I said, for every log graph, negative infinity to positive infinity. The asymptote, we already talked about, x equal negative 2. Decreasing, this is decreasing all along the domain, so negative 2 to infinity. And this increasing is NA. Whoops, missed a slide here. No, that's slide 5. Evaluate each logarithm without using the calculator. So you're asking 3 to what power is 27? That's 3 cubed. And then 2 to what power is 32? So 2 to the 5th. You don't have to write this on your quiz, but I'm going to write it here because 3 cubed is 27. And this one is because 2 to the 5th is 32. This one is negative 4 because 2 to the negative 4th is equal to 1/16. And this one is negative 3 because 4 to the negative 3 equal 1/64. And then on slide 6 here, you want to solve the equations. You want to get these numbers with the same base. So 4 is 2 squared. And 8 is 2 cubed. And then equating the exponents here, you have 2 times 2x plus 1 equals 3 times x plus 2. And then 4x plus 2 equals x plus 6. If I subtract 3x from both sides, you have x plus 2 equals 6. And then subtract 2, x is equal to 4. The second one, you want to put the base of 3, so 3 exponent and 27 is 3 cubed. So equating the exponents again, 2 times 3x plus 2 equals 3 times x plus 3. And then 6x plus 4 equals 3x plus 9. And then subtracting 3x, you have 3x plus 4 equals 9. And then subtracting 4 from both sides, x equals 5. And then divide by 3, so x is 5/3. And then the next one, 8 is 2 cubed. And 16 is 2 to the 4th. And you have 3 times x plus 1 equals 4 times 3x plus 2. So 3x plus 3 equal 12x plus 8. And then subtracting 3x. So 3 is equal to 9x plus 8. And then subtracting 8, negative 5, 9x. And then divide by 9. So x is going to equal negative 5/9. Let me go back and check my math here. Everything looks right. And the last one, if I notice that I could put this in powers of 2, but if I just put it in powers of 4, should get the same answer. So 4 exponent x plus 2 equals 4 squared to x plus 3. So equate the exponents x plus 2 equals 2 times 2x plus 3. And then x plus 2 equals 4x plus 6. And then subtracting x from both sides, 2 is equal to 3x plus 6. And then subtract 6, negative 4 equal 3x. And then divide by 3. Whoop. So negative 4 thirds is equal to x. My math here looks right. So just reviewing each problem, just reviewing the answers here. The first one, x equal 4. Second one, x is 5 thirds. The third one, x is negative 5 ninths. And the last one, x is negative 4 thirds. All right, on slide 7, it says what transformations are happening to create the blue graph log of x minus 2 plus 3. How did it change compared to the original? So if this translates right 2 and up 3. Probably should have enlarged all the slides there. All right, so what's the domain? I'm going to talk about the blue graph again. So 2 to infinity. The range of every log function, negative infinity to positive infinity, are all real numbers. The asymptote is x equal 2. The decreasing interval is NA. And increasing all along the domain, which is 2 to infinity. So reviewing the answers one at a time here. The translation or the transformations are translates to right 2 and up 3. The domain is 2 to infinity. The range negative infinity to positive infinity. The asymptote is x equal 2. Decreasing NA, increasing, same as the domain 2 to infinity. Number 8. So you want to look at the green graph, log of negative x plus 1. So this is horizontal reflection or reflected over the y-axis, horizontal reflection, and the other transformation translates up 1 unit. The domain of the green graph is negative infinity to 0. And the range is always all real numbers for logs. Asymptote is x equals 0, decreasing all along the domain there. And negative infinity to 0. Increasing is NA. Reviewing the answers one at a time. Reflected over the y-axis or a horizontal reflection translates up 1 unit. The domain, negative infinity to 0, range, negative infinity to positive infinity. The asymptote is x equals 0. Decreasing, negative infinity to 0. Increasing is NA. All right, so the rest of the slides are to try to connect these stars together with a log base 2 graph. The first one here tells you that the transformations that are going to occur is translates left 3 and down 2. So log, and then they say use the underscore for the subscript. So log base 2 and then hit the right cursor key. Left 3 would be x plus 3. So negative 3 is the asymptote there. And then down 2, it will be log base 2 and in parentheses x plus 2, x plus 3 minus 2. That connects together all the dots. And if you launch the marbles, then it collects all the stars. In slide 10, you're going to do a log base 2 function again. The transformation is reflected over the x-axis, so vertical reflection, and translates right 1 and up 2. So vertical reflection is a negative in front of the log. And then right 1 would be x minus 1. And then up 2 plus 2. And that goes through all the stars. And when I launch the marbles, it goes through all those stars. Number 11, you want to do log base 2 again, and the transformation is reflected over the y-axis, so horizontal reflection, and down 1, so log base 2. And then reflected over the y or horizontal is negative x. And down 1 would be minus 1. And then the rest, it's not giving you any hints, but they're all log base 2. Right, so what I would look for here, this looks like the asymptote here at -1, so, or a +1, sorry. So I just subtract 1. All right, so now I got the asymptote. Then I want to move this graph up somewhat. All right, so let's try +2. Oh, didn't work. Move it up a little bit more. So the first thing I do is try to determine the asymptote there. That's what's going to affect what's inside the parentheses. And then I did +2, but that didn't work. So I added another unit. So I moved up 3, and that connected all the dots together. All right. It's also going to be log base 2. And then this asymptote looks to be at -1. So x plus 1. Then I want to reflect this over the x-axis, so put a negative in front of there. Okay, that's almost right. Now I have to move this graph down somewhat. So let's try -2. Oh, let's try -3. There we go. So first I look for the asymptote. I got it right here is a -1, x equal -1. And then I realized I had to reflect the graph over the x-axis, so I put a negative in front of that. And then I adjusted this so it went through the stars. I tried -2 first, that didn't work. So then I did a -3. All right. And then 14, you want to do log base 2 again. And then x. Well, that doesn't quite work because we want to be over on the other side. So I'm putting a negative in front of there. So I'm almost there. Now I just have to go through the stars. So just go +1. And then 15 on log base 2 again. All right, and we want to, let's see. I want to flip it over reflect it over the x-axis. So put a negative. And then look at this asymptote here. It's at 1, 2, 3, -3. So let's do +3 here. All right, and then I have to move this up a little bit. So if I look right here, in here, it looks like up 2. So +2. There we go. And then 16. One reason use log base 2 here is so we can look at grid space a little bit better. The bigger the base, the more spread out the graph would be. So, or the stars would be. So the stars are a little bit tighter together. If I use log base 2, that's why I use log base 2. So if I do log base 2 of x, and I want to reflect it over the y, so this is going to be a negative in front of there. Then I look at the distance between here and here. So 1, 4, it looks like 4. 1, 2, 3, 4. Let me try -4. Yep, that works. All right, so that's the extra practice, and then your quiz won't be Marvel slides, but it will be transformations of logs, evaluating logs, and solving exponential, and finding the key features of a log function. It won't be 16 slides. I think it's about 5 slides, 5 or 6 slides, I think. So your quiz will be 6 slides, but it'll be a lot less. Then there'll be a couple of transformation, a couple on key features, slide on evaluating logs, slide on solving an exponential equation.